This is the first lesson 1-2, points, lines, and planes. So we're going to go over some basic geometry vocabulary that you're going to add to your notes, and we'll use this throughout the year. Geometry is a mathematical system built on accepted facts, basic terms, and definitions. The first thing we're going to go through are some undefined terms. Undefined terms are the basic ideas that you can use to build the definitions of all other figures. So the first undefined term that we're going to talk about is a point. A point indicates a location and has no size. This can be represented by a dot, and we name it by a capital letter. So right here is an example of a point, and we call this point A. So you're going to add this to the notes section of your sheet. So you're going to write down the word, which is point. You're going to write down the definition. It indicates a location and has no size. And you're going to draw a picture of it and give an example of a point in real life. Okay, so a point is one of our first undefined terms. If you need to stop the video at any time, pause it so you can copy down the definition or copy down the picture or whatever you need to. Another undefined term that we have is line. A line is represented by a straight path that extends in two opposite directions without end, and it has no thickness. Okay, again, you're going to add this again to your sheet with your word and your definition and your picture. So a line contains infinitely many points. So along this line, I call this line AB. There's a few names I can use, but one is line AB. I use 2 points that are on the line, but there are infinite number of points along this line. And the line, as you can see, has arrows. It continues infinitely in either direction. Now I can name the line by any 2 points on the line, so I can call it line AB. So I write the AB and I write a little mini line above it with arrows. Or I could use the letters in the other order and I could call it line BA. Or I could always use a single lowercase letter such as line L. So if there's an L right here outside of the line right next to it but not a point on it, I can use a single letter like that. So a line is represented by a straight path. It extends in two opposite directions without end, and it has no thickness to it. So you're going to write down the word, the definition, and the picture, and an example if you can think of an example in real life, and pause if you need to. Another undefined term is a plane. A plane is represented by a flat surface that extends without end, and it has no thickness to it. A plane contains infinitely many lines. So a plane is just a flat surface. It extends infinitely in all directions, but when we think of a plane in geometry, we might think of a figure such as a quadrilateral, or think of your desk, think of the blackboard, think of the wall. It's just a flat surface. Now you can name a plane by a single capital letter, like I have a letter here. This is not a point because there's no dot next to it, but I can just call this plane P. Or I could pick at least 3 points that are on the plane that do not lie on the same line. Like I can call this plane ABC. So I pick any 3 points, but those 3 points can't be on a line. Otherwise, I wouldn't know if I was talking about a line or a plane. Okay, so that's another undefined term is plane. Collinear points is another word that we're going to define. Collinear points, or points that lie on the same line. Okay, so collinear points are points that lie on the same line. And then I also have something called coplanar. Coplanar are points and lines that lie in the same plane. So here's an example of a plane up here. And coplanar, so any points like A, B, C, they lie in the same plane, those are coplanar. Any lines that lie in the same plane are coplanar. If I connected AB, I have a line. If I connected BC, I have a line. They lie in the same plane. They are coplanar. Okay, we have just a few more definitions to do. The next one is a segment. A segment is a part of a line that consists of 2 endpoints and all the points between them. So a segment has a beginning and it has an end. It does not have arrows. It does not continue infinitely in either direction. It's just a part of a line, a segment of a line. So when I'm using the notation, again I use the 2 letters like AB, but this time I just have a line segment above it. I don't have arrows on that. I can also call this BA if I wanted to. So a segment's another one of our words that we're going to define. It's part of a line that consists of 2 endpoints and all the points between them. Another definition that I have is array. Array is part of a line that consists of one endpoint and all the points on the line on one side of the endpoint. So array, if you look at the example right here, the picture, A is an endpoint and B has an arrow that continues forever and ever. So it's part of a line, it has one endpoint and all the points on the other side of that line. So when I'm using notation, again I use the two letters like AB. The order of the points indicates that the ray's directions. So the A is the endpoint and the B is by where the arrow is, so then I know which direction that ray is going. Okay, think of a ray, maybe you think of the hands on a clock, how they have the arrows at the end of them. If I take two rays and I put them together and they share the same endpoint and form a line, those are called opposite rays. So opposite rays are two rays that share the same endpoint and together they form a line. So here I have ray AB, which is starting at A and it's going off to the right. And I also have ray AC, which is also starting at A, but it's going towards C. It's going off to the left. So they share the same endpoint, which is A, and together they form a line. Okay, so those are opposite rays. Now that's it for our words that we're going to define today, but we have a few postulates that we're just going to go through. And most of these are written on your note sheet, but you can just add to it what needs to be added. A postulate or axiom is something that is an accepted statement of fact. So the first one that we have is through any 2 points there is exactly one line. So if I have 2 points A and B, there's only one line that can be drawn through those 2 points. Line T passes through points A and B. Line T is the only line that could pass through both points. So there's only one line that can go through 2 points. Another postulate that we have is if 2 distinct lines intersect, then they intersect in exactly one point. So I have line AE right here, and I have line DB. They're 2 separate lines. They intersect in exactly one point, and that point is point C. So you're going to just add this line AE. I write the AE with the little arrow above it, the little line symbol, and line DB intersect in point C. So 2 lines intersect in exactly one point. Another postulate we have is if 2 distinct planes intersect, then they intersect in exactly one line. So I have plane RST, okay, which is the blue plane right here, and that intersects with plane WST, which is the yellow plane right here. And they intersect in one line, and that line is ST. So 2 planes are going to intersect, and they intersect in one line. Think about the walls of a room, like the front wall of the room and one of the side walls of the room. They intersect in that corner there, and that corner is a line. Another postulate, the last one we have, through any 3 non-collinear points, there is exactly one plane. So I have points Q, R, and S. They're non-collinear. I can't form a line with them. Plane P is the only plane that contains them. Okay, and that's it for today. So make sure you come in tomorrow with your notes ready, and we're going to do the do now, which is based on some of the notation that we've learned.